CAPST, Center for Applied Physics and Superconducting Technologies, is a center that brings together Northwestern University, in particular the Department of Physics, and Fermi National Accelerator Laboratory, in particular scientists from the technical division, to study the mysteries of superconductivity.
Fermilab is a leader in developing superconducting RF cavities for particle accelerators. The Northwestern physics faculty and material science faculty are experts in the field of superconducting materials, the theory of superconductivity. And that expertise, combined with Fermilab's technical expertise, is what we need in order to advance the performance of the next generation of particle accelerators.
CAPST serves the important purpose of training the new generation of accelerator scientists who will work on quantum technologies, on accelerator technologies, from academia into national laboratories.
Fermilab has outstanding facilities, and they have technical expertise in applied superconductivity.
Here at Fermilab, we discovered something very important called nitrogen doping of these structures, which have boosted the efficiency of the structure a factor of 4. CAPST is really what will help us bringing together the experts from university, from academia and national lab, understanding why is nitrogen working and how can we push further the envelope of the technology.
The roles of CAPST actually to educate the next generation of people who hold knowledge actually about both scientific part and technology part, so scientific part being at Northwestern mostly and technology part at Fermilab.
Research on quantum computation in general will have a pretty remarkable impact. 5 years, 10 years from now, we'll really get to experience how much more powerful quantum computers are as compared to our traditional computers, even the best supercomputers we have today.
CAPST helps me in my research in the combination of talent from the Fermi National Accelerator Laboratory with my colleagues here at Northwestern that articulate important questions that are limiting us in applying superconductivity for accelerator cavity performance and for quantum information.
It's a fantastic opportunity both for senior researchers but then also for our students and postdocs to learn from each other and be engaged in a collaborative effort.
Where CAPST wants to play a role is the development of next generation of technical experts and scientists, both doing basic research in superconductivity and applications of superconductivity for next generation technologies.
The partnership between Northwestern University and Fermilab is very important because it brings together two different and unique skill sets: the fundamental understanding of superconductivity and the applied knowledge of how the superconductors work. We can actually advance the technologies that are at the core of these particle accelerators. In the national labs, we often lack enough postdocs and students, so we really want to build this hub to train a new generation of young scientists that will actually make an impact in this field.
The interactions between those at the National Fermi Accelerator Laboratory and here at Northwestern, that will serve as a base for training students, training postdocs, training researchers, who then can move this application of superconducting technology to improving our society to the next level.
I hope to see that these technologies will advance to a point where we can build more powerful accelerators that will reach higher energy, higher efficiency. I hope that we can advance the technologies for quantum computing. So there is a variety of different applications that we can have a very important impact on by just pushing the fundamental understanding of the superconductors that we utilize in this technology.
On the short time scale, we aspire to be able to understand properties that have not yet been carefully measured and build theory, which will allow the applications of the superconductors of today to improve the impact that it has on society in both medicine and in basic science. On a longer time scale, we hope to have new materials. We hope to be able to use the ideas we have from the past to develop techniques that will give us capabilities for quantum information and coherence of the quantum state, which are so essential. And importantly, will be the recognition on a worldwide scale of the importance of doing science this way. And hopefully that will have a tremendous impact, not just in the superconducting technologies that we're talking about here, but broadly in basic science applied to technological goals.